Hey all, Mr. Myers is here again with you today, and we're doing the second part of that normal distribution video here with the TI-84. So in this one, we're going to do percentiles. So let's get to it. Okay, make myself small. So on the last video, we had this problem here where we're talking about supervillains and their power ratings, and I created your normal distribution given with the empirical rule. So here we got power ratings of supervillains. I need to put a picture on here like a supervillain. Like, what kind of supervillain you guys like? Thanos, that's a pretty big guy, right? Put him down way over here somewhere. Very high standard, very high Z-score, right? Pretty powerful dude. So anyway, let's get to this. What we're going to look at specifically is looking at percentiles in the normal distribution, and we'll use the TI-84. So I just left this on the screen for a second in case you're new to this video and you didn't watch the first video. You can at least have the problem for you. Okay, so the problem that we're going to do today, we got two problems here. The first one is, what would be the power rating for a villain that is at the 70th percentile? So just bring you back a little bit, remember that a percentile is the value at which that percent is below. So what we're talking here is that what is the power rating so that 70% of all villains are below that power rating, all right? So if I was looking at the normal distribution, what I would be looking at is all this shaded area here, all that is 70%, so 0.7. What I'm interested in knowing is what is this value here given the power ratings that I have. So what I would like you to do is I would like you to find a Z-score. Now you can do this straight away in the calculator, but we first need if we could find the Z-score here, we can determine what this value is going to be in terms of the power rating. So we're going to take our formula for Z, which is x minus mu over sigma. And we are going to need to find out, if we plug everything in here, we have x, which we don't know, mu, which we know to be, let me go back up here, what was mu? 43, 43, 43, and sigma, which is 12.5. And what we don't know is z. All right, so we need the z-score here. So we have got two variables we got to deal with, but we can find z, because all we're asking is, what is this z-score if this area in here is 70%? Well, there's a function in our calculator that does that for us. So we are going to use the calculator. So I'm going to pull up my TI-84 here, and we're going to go to second vars, which is going to take us into distributions, D-I-S-T-R, R. It's the pirates. R. Okay. We use normal CDF to find the area, but since we already know the area, we want to find the inverse of that. So we're going to use the function called inverse norm. So it's the third option here. So we're going to hit enter there, inverse norm. The area that we're looking for, now the calculator only calculates areas that are below a value. So if we were looking above a value, we'd have to subtract 1 from that percentage. But this, we already know it's 70th percentile, so it's pretty easy. So we're going to put 0.70 in here. And since we're dealing with, oops, I'll hit enter. Sorry, I'll hit down. Since we're dealing with the z-score and since we're dealing with z-scores, we're going to leave the mu as 0 and the standard deviation is 1. Okay, so don't change these. Because we're looking for a z-score. The tail is left. Oh, look at that. This is an updated version. So this one will allow you to do a tail to the right, an area that's above. That's kind of nice. We're just going to leave it at left because that's where we're going. And we'll hit paste. We'll hit enter. Okay, and then we're not done yet because that's just the function. Now we have to enter again. And there we go. We got 0.5244. So that's our z-score. For the most part, z-scores can be left in 2 decimal places. So 0.52 is sufficient for this one. So I'm going to go 0.52. X minus 43 over 12.5 equals 0.52. And then I'm going to solve for x. So I'm going to do a little algebra here. X minus 43. I'm going to multiply both sides by 12.5. And then I'm going to add 43 over. Okay, so this is just some algebra. I know some of you are like, I was told there wouldn't be any math in this class. Well, It is a math class, right? Okay, so we're going to do some, what have we got here? 0.52 times 12.5 plus 43, 49.5. All right, so that's our answer, is 49.5. All right, so that's the power rating. That's the 70th percentile. So there we got a percentile. Now, if you wanted to go straight from the problem to your answer, which your TI-84 will be able to do that. So here's what we do in this case. We're going to do inverse norm again. So I just want to show you that you can do this, but I'd like to, if you were in my class, I'd like to see your work. 0.7 is our area again, and now mu is going to be, what was our, you're probably saying in here, hey, it's 43, my S's, come on. How can you forget that? God, it's early, guys. It's early, and I've been in lockdown for like almost 10 days. Give me a break. 12.5, all right, and paste that. Enter. Enter, boom, 49.5. All right, and again, it's got some more decimal places here because it used a huge z-score there. It gave us not a huge, but a more precise, so it's going to be closer. But 49.5 statistically, that's all we're looking for. Okay, so let's do another problem that's similar to this that you often see, and that is determining the IQR. So when we're looking at the IQR, we're looking for the third quartile minus the first quartile, and you learned that way back weeks ago. So what we're going to need to do is we're going to need to find the third quartile and find the first quartile. So remember that the third quartile matches up to the 75th percentile, and the first quartile matches up to the 25th percentile. Now, the great thing about this is that the normal model, I know, I'm so excited about this, right? You guys are like, come on, is perfectly symmetric. So whatever the 25th percentile is going to be, whatever this z-score is here, it's going to match the z-score there, only one's going to be negative and one's going to be positive because the areas are all the same. So what we could do is find that. So let's go and do that in that z-score that matches with the quartiles, okay? So we're going to go second, distributions, we're going to inverse normal that. And I'm just going to do 0.25 because that's going to give me the first quartile. I got to change this back to 0 and 1 because I'm looking for z-scores. And now I'm going to paste that guy. And let's see what it gives me. It gives me negative 0.674. Let's go with negative 0.674. Let's go 3 decimals. Normally z-scores, well, let's go to, I said z-scores, you can go 2. So we'll go 2. 2 after the decimal point. So we're going to go negative 0.67. So the first quartile matches up with negative 0.67. What do you think the third quartile matches up with? Wait time. You're right. Positive 0.67, right? It's symmetric. I just told you that earlier. So what we're going to do is we're going to use these scores. We're going to do a similar thing that we did here with this previous one. And we're going to find those values that match up to each of those quartiles. So we're going to find the quartiles. And then we're going to subtract. All right. So here's what I'm going to do. For Q3, remember that we had z equals, I'm going to use Q1 here. I said Q3, I know, but I'm going to use Q1 minus mu over sigma. Now, some of you are like, well, where did you get Q1 from? Well, that's our x value. So instead of x, I just put Q1 because that's the value I'm looking for. I'm going to do some math here to make it a little simpler. So I'm going to multiply by sigma, and I'm going to add mu over. Oops. Plus mu equals Q1. So if you want, you can just kind of think about this formula as being the formula that you're going to use to find a percentile. Actually, this will work for anything. You just got to make sure you have the z-score there. All right, so let's go ahead and use that. So Q1 is going to be equal to z times sigma plus mu. So z is going to be negative 0.67. Now we just got that right here. Times mu, which was 12.5, plus 43, I believe. All right, and we'll go ahead and calculate that. We get 34.625, and we'll go ahead and do Q3 the same way. Z times sigma plus mu. We'll go positive 6.67, times 12.5, plus 43. And we're going to get, I typed it up here, it's 51.375. And now we want our IQR, And our IQR is Q3 minus Q1, so I'm going to take 51.375, subtract 34.625, and we are going to get, let's see, minus 34.625. Oops. I tell you, this, can't do anything with it. 16.75. Okay. 16.75. All right. So just to, once again, that's how you use the TI-84, and we're using the normal model to find percentiles. So hopefully that helped out, and if you were in my class, that kind of summarizes that first big piece. So thank you for watching part 2. Stay safe, everyone, and don't forget to subscribe. We'll see you next time.